Chapter 9, Section 3, Math Analysis. Today we're going to be doing polar and rectangular coordinates. I'm your host, Dr. D. Okay, so first of all, like we've been talking about for the last couple of days, polar coordinates are some r theta. Meaning some distance from the center and some angle, some direction. So distance, direction. Now, rectangular coordinates are some direction in right or left and up or down. Okay, so the goal today is going to be that you're going to be able to translate from polar to rectangular and rectangular to polar. So let's get the basic formulas that you're going to need to know. And you really already know them. So if I have polar coordinates and I want the rectangular coordinates, then here's how I do it. X equals r cosine theta. You may recall that from last chapter. X equals r cosine theta, and what do you think y will be? Very good, boys and girls. It's r sine theta. Okay, so if you give me an r and a theta, then I can give you an x or a y. Now, let's go the other direction. Now I want to go from rectangular to polar. So that means I have the x and y, and I need the r and the theta. Okay, so r is going to be the square root of x squared plus y squared. The radius is basically your hypotenuse. And the theta is going to equal inverse tangent of y over x. Okay, so just to be able to see how this works, we're going to take our here's a basic point. Now, if we have our polar coordinate, then that's going to be r at theta. R, the distance from the origin to the point, and theta, the angle from 0 degrees. There's my y, there's my x. So, you can see that x equals r cosine theta, because if I take cosine theta, that's going to be x divided by r, so r times cosine theta will be x. And sine theta is y divided by r, so that means y equals r times sine of theta. Now, if I already know the x and the y, then I get my r by just going square root of x squared plus y squared. That's Pythagorean theorem. And then I know that my theta is going to be the inverse tangent of y over x. So that's simple. Just remember polar to rectangular, rectangular to polar, and that's really the whole lesson. So let's try some examples. Okay, so if I have a point five 2 pi over 3. And I want to change that to rectangular. Okay, so all I do is say x equals 5 cosine 2 pi over 3, and y equals 5 sine 2 pi over 3. Well, cosine of 2 pi over 3 is negative 1/2. And sine 2 pi over 3 is positive square root of 3 over 2. So x is going to equal negative 5/2, and y is going to equal 5 square root of 3 over 2. So my rectangular coordinate is just going to be negative 5/2, comma, 5 square root of 3 over 2. That's it, game over. No calculator was required in the making of this omelet. Okay. So now, let's say we have a point negative 13, negative 70. Okay, so the point is negative 13, negative 70 degrees. We do the exact same thing. X equals negative 13 yeah, we could just do this. Negative 13 cosine. Negative 70. And y equals negative 13 sine negative 70. So, clearly we don't know 70 degrees. Sine or cosine 70 degrees. So we punch that puppy out in our calculators, and we end up with negative 4.45 and negative 3.45. Wait, and positive 12.22. Now, with both of these, we really should test it out to make sure we have it in the right place. So, if I look at my 5 at 2 pi over 3, where is that? Well, that's going to be two pi over 3 goes up here, and it's going to be 1, 2, 3, 4, 5 up there. So there's my 5 at 2 pi over 3. Now, what I'm saying is that this is 2.5 left and 2.5 times square root of 3 up. So basically I know this is going to be true because this is a 30, 60, 90 right triangle. So the short side is half the hypotenuse and the long side is the square root of 3 over 2 times the hypotenuse. So, or I'm sorry, square root of 3 times the short leg. So that makes 5 halves times square root of 3. So we've got 1/1/2 square root of 3 over 2. And so there's our 30, 60, 90 right triangle. Now, same thing over here. If I want negative 13 at negative 70, well, first I need to measure the negative 70 degree angle. So that's going to be down here, negative 70. Remember, it's not positive 70. Well, now, negative 13 is up this direction. So it's 13 up this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, we need an extension. Okay, there's 13 up here. 13 away from the negative 70. So that says that we're 4.45 this way, negative 4.45 means 4.45 to the left, and then 12.22 up. So that's reasonable. Okay, now let's go the other direction. So let's say we're given negative 8, negative 12. Okay, so negative 8, negative 12, and I want polar coordinates for that. So, r equals the square root of negative 8 squared plus negative 12 squared. So clearly the negatives don't matter. So this is going to equal the square root of 64 plus 144, which equals the square root of 208. Which is approximately 14.42. Okay, now theta is inverse tangent of y over x. Now, remember, your calculator doesn't know the difference between 12 over 8 and negative 12 over negative 8. So, remember, we're left and down here. And so, I'm sorry, yeah, down and left. And so, that means we're in the third quadrant. When you do inverse tangent from your calculator, you're going to end up with an angle in the first quadrant, which okay, that angle is going to end up being, let's see, I'm just going to do this myself. Okay, so 12 over 8 is 1.5, and when I take the inverse tangent of that, I get 56.309 degrees. Now, 56.309 degrees, Now let's make it 56.31 degrees. That's not the right quadrant. I'm in the third quadrant, so I need to add 180 to that. So I end up with 236.31 degrees. And so my polar coordinates are going to be 14.42 at 236.31 degrees. Or, if I want this in radians, then I can do the exact same thing. Just make sure your calculator's in the radian mode. Now, I go inverse tangent of 1.5 and I end up with 0.98279. So we'll just say 0.983 radians. Now, once again, I'm in the first quadrant, so I have to add pi to get to the third quadrant. So when I add pi, I end up with about 4.124. So in radians then, this would just be 14.42, same magnitude, and the radians would be 4.124. Now notice, degrees, I have to put the degree mark above it. Radians, I just leave it a plain number and it's understood that that's radians. Okay, now, there's one more thing that we're going to be doing, and that's translating polar equations into rectangular equations, and rectangular equations back into polar equations. So notice we're going to go back to the beginning, and this is our translation still. X equals r cosine theta, y equals r sine theta, r equals square root of x squared plus y squared, theta equals inverse tangent y over x. So if we try the example, let's write the polar equation r equals 6 sine theta in rectangular form. Okay, that's a polar equation because it's got r and theta in it. We want to change that to a rectangular equation. So what we want to do is, I know that r sine theta is y. So if I just multiply both sides by r here, then I have r squared equals 6r sine theta. So now when I change that to rectangular, I know r squared is x squared plus y squared. Remember that little thing called the Pythagorean theorem. And then we have r sine theta is 6y. Now I've taken an equation with r and theta in it, and I've changed it into an equation with x and y in it. And that's it. Game over. Okay, now let's go the other direction. So, x minus 3 quantity squared plus y squared equals 9. All right, now, this is an equation with x and y in it, and I need to change it into an equation that's got r and theta in it. So what I'm going to do is go, instead of saying r squared equals x squared plus y squared, I'm going to go the other way around and say x equals x equals r cosine theta, y equals r sine theta. So let's just distribute this. I think that's going to be easier. So we've got x squared minus 6x plus 9 plus y squared equals 9. Okay, so x squared is r squared cosine squared theta. Minus 6 times r cosine theta plus 9 plus r sine theta squared equals 9. Well, now clearly the 9s are going to cancel, so we could have done that already. But the other thing I wanted to show you is we've got here r cosine theta quantity squared, so that gives us r squared cosine squared theta minus 6r cosine theta plus r squared sine squared theta equals 0. The 9's cancel. Now, I'm going to take my r squared cosine theta, r squared sine theta, and make r squared times the quantity yeah, we'll just keep this. Minus 6r cosine theta equals 0. Okay, now, you might remember from a couple of chapters ago, sine squared plus cosine squared equals 1. So now I just have r squared minus 6r cosine theta equals 0. Now, I could factor an r out of here and make it r times r minus 6 cosine theta equals 0. So, there's basically an equation. We started with x and y, and we ended up with r's and thetas. Yeah, then the last step is they divided out the theta, so we end up with r equal, or divided out the r, so r equals 6 cosine theta. That's basically simplest form. So, notice we start with r's and thetas, we turn into x's and y's. We start with x and y's, we turn into r's and theta. That's the whole thing for today. So, have fun with these.